सो हाय एवरीवन, वेलकम बैक टू अनदर वीडियो। तो आज हम देखने वाले हैं फिजिकल फार्मेसी का जो स्टेट ऑफ मैटर करके चैप्टर आता है। ये बेसिकली मार्टिन फिजिकल केमिस्ट्री फिजिकल फार्मेसी का बुक है, ठीक है। तो इसमें स्टेट ऑफ मैटर आज हम बुक रीडिंग में शामिल करने वाले हैं, ठीक है। तो इसमें चैप्टर ऑब्जेक्टिव में हम क्या देखेंगे? एट द कंक्लूजन ऑफ दिस चैप्टर द स्टूडेंट्स शुड बी एबल टू understand the nature of intra and intermolecular forces that are involved in stabilizing molecular and physical structure, understand the difference in these forces and their relevance to different type molecule, discuss supercritical state to illustrate the utility of a supercritical fluid for crystallization and microparticulate formulation, appreciate the difference in the strength of intermolecular forces that are responsible for the stability of the structure in different state of matter, perform calculation involving the ideal gas laws, molecular weight, vapor pressure, boiling point, kinetic molecular theory, van der Waals real gases, and Clausius-Clapeyron equation, heat of fusion and melting points, and the phase rule equation. Understand the properties of the different state of matter. Describe the pharmaceutical relevance of the different state of matter to drug delivery system by reference to the specific example given in the text box. Describe the solid state, crystallinity, solvates, polymorphism. ठीक है। Describe and discuss key technique utilized to characterize the solid. Recognize and elucidate the relationship between differential scanning calorimetry, thermogravimetric, Carl Fisher Surson analysis in determining polymorphic versus solvate detection. उसके बाद 11 में अंडरस्टैंड फेज इक्विलिब्रिया, फेज ट्रांजिशन बिटवीन द थ्री मेन स्टेट ऑफ मैटर, understand the phase rule and its application to different systems containing multiple components, binding force between the molecules. क्या गर्मी आज हो रहा है, हे प्रभु, बहुत ज़्यादा गर्मी हो रहा है। Binding force between molecule. For molecule to exist as aggregates in gases, liquid and solid, intermolecular forces must exist. An understanding of intermolecular forces is important in the study of a pharmaceutical system and follows logically from a detailed discussion of intramolecular bonding energies. Like intramolecular bonding energies found in covalent bond, intermolecular bonding is largely governed by electron orbital interaction. The key difference is that covalency is not established in the intermolecular state. Cohesion or the attraction of like molecules and adhesion or the attraction of unlike molecule are the manifestation of intermolecular forces. Repulsion is a reaction between two molecules that forces them apart. For molecules to interact, these forces must be balanced in an energetically favored arrangement. Briefly, the term energetically favored is used to describe the intermolecular distance and the intramolecular conformation, where the energy of the interaction is maximized on the basis of a balancing of attractive and repulsive forces. At this point, if the molecule are moved slightly in any direction, the stability of the interaction will change by either a decrease in attraction when moving the molecules away from one another, or an increase in repulsion when moving the molecules towards one another. Knowledge of these forces and their balance matlab equilibrium is important for understanding not only the properties of gases, liquid and solid, but also interfacial phenomena, flocculation in suspension, stabilization of emulsion, compaction of a powder in capsule, dispersion of a powder or liquid droplets in aerosol, and the compression of granules to form tablet. With the rapid increase of a biotechnology derived product, it is important to keep in mind that these same properties are strongly involved in influencing biomolecular. Example हो गया protein DNA, secondary, tertiary and quaternary structure, and that these properties have a profound influence on the stability of these products during the production, formulation and storage. Further discussion of biomolecular products will be limited in this text, but correlation hold between small molecule and the larger biomolecule therapeutic agent due to universality of the physical principle of chemistry. Now, repulsive and attractive forces. When molecule interact, both repulsive and attractive forces operates. As two atoms or molecules are brought close together, the opposite charges and the binding forces in the two molecules are closer together than the similar charges and forces, causing the molecules to attract one another. The negatively charged electron cloud of the molecule largely govern the balance matlab equilibrium of the forces between the molecule. When the molecule are brought so close that the outer charge cloud touch, they repel each other like rigid elastic bodies. Thus, attractive forces are necessary for molecules to cohere, whereas repulsive forces act to prevent the molecule from interpenetrating and annihilating each other. Moelwyn and Hughes one pointed to the analogy between the human behavior and the molecular phenomenon. Just as the action of human are often influenced by a conflict of loyalties, so too is a molecular behavior governed by attractive and repulsive forces. Repulsion is due to the interpenetration of the electronic cloud of the molecule and increases exponentially with a increase in distance between the molecule. At a certain equilibrium distance about 3 से लेकर के 4 into 10 to the power 8 minus 8 सेंटीमीटर जो कि 3 से लेकर के 4 एंगस्ट्रम, the repulsive and attractive forces are equal. At this position, the potential energy of the two molecules is a minimum and the system is most stable. Figure 2.1. This principle of minimum potential energy applies not only to the molecule but also to atom and to large objects as well. The effects of repulsion on the intermolecular three-dimensional structure of a molecule is a well illustrated in considering the conformation of the two terminal methyl groups in butane, where they are energetically favored in trans conformation because of a minimization of the repulsive forces. It is important to note that the arrangement of the atom in a particular stereoisomer gives the configuration of a molecules. On the other hand, conformation refers to a different arrangement of atom resulting from rotation about single bonds. ना ये तो फिगर सारा चीज़ है, अब बाकी कहाँ बच गया, ये फिगर है, यहाँ पर ये रिपल्सन हो रहा है, अट्रैक्शन हो रहा है. Okay. So van der Waal interaction are weak forces that involve the dispersion of a charge across a molecule called a dipole. In a permanent dipole, as illustrated by the peptide bond, the electronegative oxygen draws the pair of electron in the carbon-oxygen double bond closer to the oxygen nucleus. The bond then becomes polarized due to the fact that the oxygen atom is strongly pulling the nitrogen lone pair of the electron towards the carbon atom, thus creating a partial double bond. Finally, to compensate for valency, the nucleus of the nitrogen atom pulls the electron pair involved in the nitrogen hydrogen bond closer to itself and create a partial positive charge on the hydrogen. This greatly affects the protein structure, which is beyond the scope of this discussion. In Kissom forces, the permanent dipoles interact with one another in an ion-like fashion. However, because the charges are partial, the strength of the bonding is much weaker. Debye forces shows the ability of a permanent dipole to polarize charge in a neighboring molecule. In London forces, two neighboring neutral molecules, for example, aliphatic hydrocarbon, induced partial charge distribution. If one conceptualizes the aliphatic chain in the lipid core of a membrane like a biologic membrane or a liposome, one can imagine the neighboring chain in the interior as inducing a network of these partial charges that helps hold the interior intact. Without this polarization, the membrane interior would be destabilized and lipid bilayer might break down. Therefore, London force gives rise to the fluidity and cohesiveness of the membrane under normal physiologic condition. Now, van der Waal forces. Hey Prabhu. Van der Waal forces relates to the non-ionic interaction between the molecule, yet they involve charge-charge interaction. See key concept box on van der Waal forces. In organic chemistry, numerous reactions like nucleophilic substitution are introduced where one molecule may carry a partial positive charge and be attractive for interaction with a partial negative charged nucleophilic reactant. These partial charges can be permanent or be induced by a neighboring groups, and they reflect the polarity of the molecules. The converse can be true for electrophilic reactant. The presence of these polarities in the molecule can be similar to those observed with a magnet. For example, dipolar molecules frequently tend to align themselves with their neighbor so that the negative pole of one molecule points towards the positive pole of the next. Thus, large group of molecules may be associated through weak attraction known as dipole-dipole or Kissam forces. Permanent dipoles are capable of inducing an electric dipole in non-polar molecule which are easily polarizable. To produce dipole-induced dipole, Debye interaction and non-polar molecule can induce polarity in one another by induced dipole or London attraction. This latter forces deserves additional comment here. The weak electrostatic force by which nonpolar molecules such as hydrogen gas, carbon tetrachloride and benzene attract one another was first recognized by London in 1930. The dispersion or London force is sufficient to bring about the condensation of nonpolar gas molecules so as to form the liquid and the solid when molecules are brought quite close to one another. In all three types of van der Waals forces, the potential energy of attraction varies inversely with the distance of separation. R raised to the 6 power, that is r to the power 6, the potential energy of repulsion changes more rapidly with distance as shown in figure 2.1. This accounts for the potential energy minimum and the resultant equilibrium distance of separation, that is Re. A good conceptual analogy A good conceptual analogy to illustrate this point is the interaction of a opposite pole of the magnet, figure 2.2. If two magnets of the same size are slid on a table so that the opposite poles completely overlap, the resultant interaction is attractive and most energetically favored configuration, figure 2.2a. If the magnet are slide slide further so that the poles of each slide into like pole region of the other, this leads to the repulsion and a force that pushes the magnetic pole back to the energetically favored configuration. However, it must be noted that attractive मतलब opposite pole overlap and repulsive मतलब same pole overlap forces coexist. If the same charged poles are slid into the proximity of one another, the resultant force is complete repulsion. These several classes of interaction known as van der Waals forces are listed in table 2.1, are associated with the condensation of a gas, the solubility of some drugs, the formation of some metal complexes and a molecular addition compound, certain biologic process and drug action. The energies associated with primary valency bond are included for comparison. Now उसके बाद orbital overlap. An important dipole-dipole force is the interaction between pi electron orbital in the system. For example, aromatic interaction can occur when the double bonded pi orbital from the two rings overlap. Aromatic rings are dipolar in nature, having a partial negative charge in the pi orbital electron cloud above and below the ring, and a partial positive charge residing at the equatorial hydrogen as illustrated in figure 2.3a. Therefore, a dipole-dipole interaction can occur between two aromatic molecules. In fact, at certain geometries, aromatic interaction can stabilize inter and intramolecular interaction figure 23b and c, with the highest energy interaction occurring when the rings are nearly perpendicular to one another. This phenomena has been largely studied in protein, where stacking of 50 से लेकर के 60% of the aromatic side chain can often and stabilizing energy to secondary and tertiary structure, that is intermolecular, and may even participate in stabilizing quaternary interaction, that is intramolecular. Aromatic stacking can also occur in the solid state and was first identified as a stabilizing force in the structure of small organic crystals. It is important to point out that due to the nature of these interaction, repulsion is also very plausible and can be destabilizing if the balancing attractive force is changed. Finally, lone pair of the electron on atom like oxygen can also interact with aromatic pi orbital and lead to attractive or repulsive interaction. These interactions are dipole-dipole in nature and they are introduced to highlight their importance. Students seeking additional information on this subject should read the excellent review by Mayer ETAL 3. ओके ठीक है. सो आज यहाँ हम ख़त्म करते हैं. डेट है 9/6/2026. थैंक्स फॉर वॉचिंग.